All right, so I'm going to go over 2013, number 4, part B. It says, determine the absolute minimum value of f on the closed interval 0 to 8 and justify your answer. So the phrases that come out to me or stand out to me are the absolute minimum value and closed interval. When I see those, I think, okay, I should probably do the closed interval method, because closed interval method, the purpose of it is to find your absolute extrema. Okay, now they're looking for a specific type of absolute extrema. They're looking for absolute minimum value. They're not looking for absolute maximum value. Okay, so, but we can still apply the closed interval method. So now that I know I've got to use the closed interval method, I have to think, okay, what are the steps of the closed interval method? The first step is to find the critical numbers. And the critical numbers I have come from the derivative, the graph of f prime. I've got f prime. And so the critical numbers are when f prime equals 0 or does not exist. And so when I look at the graph of f prime, when is f prime 0? I would be identifying the y coordinates of f prime. So that would be at 1, at 4, and at 3. That is, I'm sorry, at 3, at 6. That is when f prime of x is equal to 0 at those x values. So those are our critical numbers. So the first step is to identify the critical numbers. Then the second step is to find the values, the y value of the function f, not f prime, of f, of the critical numbers and the endpoints. And then to put in an organized manner so that you can easily compare those values. Okay, so now that you have this here, I'm going to show it to you on my hovercam so you can see my work. All right, so we talked about the critical numbers of f of x is when f prime of x equals 0. And so our critical numbers occur at x equal to 1, x equal to 4, and x equal to 6, because that's when f prime is equal to 0. Now, I know the solutions, they don't show x equal to 1 or x equal to 4. They go straight to x equal to 6. And so I'm going to explain why they do that. And if you understand that explanation, then you can apply that in your work when you do a problem similar to this on the AP test, and it will speed up your work. So here's the thing. Since they are specifically asking for an absolute minimum and not an absolute maximum, what we want to do is find out the actual candidates that would probably give us a minimum. Now, these are candidates for an absolute extrema, but not necessarily a minimum. If you look at x equal to 1, when you look at f prime is the slopes. So the y values of f prime tell you if the function f is increasing or decreasing. So as you can see here, the y values of f prime are positive. That means f is increasing. At 1, it's a slope of 0. But after 1, the y values are positive again, which means it was increasing, slope of 0, and then it was increasing. And it continued to increase all the way up to x equal to 4. X equal to 4 is our first x value where it changes signs. So that is the first place where we would have a relative extrema. And so now it changes signs, and it changes from positive to negative. So if it changes from positive to negative, y values change from positive to negative there, then that would be a relative maximum. Now, we're looking for a minimum, or an absolute minimum. So a turning point of any kind. Now, this is the graph of f prime, but I'm just using it as a way to give you a visual. If you have a maximum, a relative maximum, that in no way is going to be a candidate for an absolute maximum. Okay, or I'm sorry, an absolute minimum. We're looking for a minimum. So a relative maximum would not be a candidate for an absolute minimum. So this one doesn't change signs. This one is a relative max, but now when I get to x equal to 6, f prime changes from negative to positive, which is a relative minimum. Now that is a candidate for a absolute minimum. Okay, so we can just use that critical number as one to test. So we're going to test the endpoints, f of 0. We're going to find the y values of this critical number, f of 6. And we're going to find the y value of the endpoint, f of 8. Okay, so this is the end, and this is the critical. And again, why we don't need these is because we're specifically looking for an absolute minimum, and there's no change signs there, so there's not going to be an absolute minimum. And this is a relative max, so it can't be an absolute minimum. All right, so now that I've got that, then let's look at what they say in this problem. They say that, well, if I want to find the values, they do give me a value, f of 8 equals 4. So f of 8 is equal to 4, which means I've got this guy. Okay,